Okay, so how do we calculate the lambda max for these compounds? So starting with compound A, we always start with a base number, which is 217. We only have two double bonds. This means that there is no need to add 30, the number plus 30, since we just have two double bonds. And then the next step is find how many alkyl groups do we have. We have 1, 2, 3, 4, 5 alkyl groups in this case. Just to remind you that the alkyl groups are the ones which are sp3 hybridized. So if the carbon which is connected to the double bond, usually we name it the allylic carbon. If it is sp3 hybridized, then you count it. If it has a double bond, then you don't count it. So anyways, we have 1, 2, 3, 4, 5. 5 times 5, that's 25. We have one exocyclic double bond, which is this one. Now, what is an exocyclic double bond? Whenever you have a cycle, and then outside this cycle you have a double bond, which has only one carbon in common with this cycle, then it's called an exocyclic double bond. I don't really care if this double bond is outside or it is within another cycle. As long as this double bond has only one common carbon with the cycle, then it is considered as an exocyclic double bond. So that's why in this case, this double bond is considered as exocyclic. That's why I'm adding 5 points here. We don't have a homoannular diene because our double bonds are not inside the same cycle. That's why for compound A, this is going to be the lambda max. Now, for compound B, we have, those are the two double bonds which count for the 217 nanometers, and then I have one more double bond. That's why I will add plus 30. So this is for the extra double bond. Now we have to count the alkyl groups. Again, this is my double bond, so these are the carbons which are next to the double bond. This 1, 2, 3, 4, and 5. Okay, so all these carbons are connected directly to the double bond and they are sp3 hybridized. That's why we count them. So we have 5 times 5, that's 25. So this is for the alkyl groups. Let's see if we have an exocyclic double bond. The only cycle that we have is this one, and we do have this double bond outside this cycle. So we have only one double bond outside this cycle. That's why I'm adding 5 here. So this is for the exocyclic double bond. We don't have a homoannular diene because we don't have two double bonds within the same cycle. That's why B is done. In C, again, we have 3 double bonds, so 217 for 2 of them, and then 30 for the extra double bond. Let's look at the alkyl groups now. So again, this is our double bond, so this is next to the double bond, next to it. You cannot count this because this one has a double bond, so you can count this one here, this one also, this one, and this one. So we have 1, 2, 3, 4, 5, 6. 6 times 5, that's 30. So this is for the alkyl groups. And then let's see how many exocyclic double bonds we have. If I started with this cycle here, then I have this double bond outside it. So this is an exocyclic double bond. Then if I took this cycle now, if I looked at this cycle now, this double bond is outside it. It just have one common carbon with it, and that's why this is another exocyclic double bond. And then one more here. So this is another cycle, and this is a double bond outside it. So we have 3 exocyclic double bonds, and that's why we have 50 here. 3 times 5, so this is for the exocyclic double bonds. And we don't have any homoannular diene because we don't have two double bonds within the same cycle. So again, C is done. For the last one, we have 3 double bonds. That's why it's 217 plus this extra bond. Regarding the alkyl groups, 1, 2, 3, 4, 5, 6, 7. We do have 7. I think there was a mistake in my previous solution. So 7 times 5, that's 15 for the alkyl groups. Let's check for the exocyclic double bonds now. This is the first cycle that we have. We do have a double bond which has only one common carbon with the double bond, so that's this one. So this is the first exocyclic double bond. This is not considered as an exocyclic double bond. Why? Because it has 2 common carbons with this ring. That's why you don't count it. However, since we have those 2 double bonds inside this cycle here, this is considered as a homoannular diene, and that's why I'm adding 39 here. So this is for the homoannular diene, this is for the exocyclic double bond, and that is D basically. To answer the last question here, which of the following compounds is expected to have the higher, larger lambda max? You don't have to really count all these, calculate the lambda max for each one of them. The reason is that in this first compound, we have 3 conjugated double bonds. In this one, you cannot count this double bond here because it's not conjugated, so ignore it. So you just have 2 doubles. And the same thing applies here. This one is not conjugated, so don't count it, so you just have 2 double bonds. And you already know that the more conjugated double bonds we have, the higher the lambda max will be. That's why in this case, without calculation, this is going to get the higher lambda max, because it has a 3 conjugated double bonds. And even if you try to calculate it, you will get the same answer.